Assalamualaikum and a very good day for all of you. So my team and I are going to present about vapor-liquid equilibrium. First of all, I would like to say special thanks to our lecturer Dr. Farah for giving us this opportunity to present our presentation inside this video, which is VLE. So my team consists of 5 members, which are 198998 Farhan Fisal, 198801 Dayana Arisha, 198421 Iman Zulika, 195844 Hakim Zainal, 199892 Ahmad Zainal. So before I start, let me ask you a question. What is VLE, or you can call it as vapor liquid equilibrium? So vapor liquid equilibrium is a distribution of a chemical species between the gas phase and the liquid phase. So the concentration of a vapor in contact with its liquid, especially at equilibrium, is often expressed in terms of vapor pressure, which will be a partial pressure, a part of the total gas pressure. If other gases are present with the vapor, the equilibrium vapor pressure of a liquid in general is only dependent on temperature. At vapor liquid equilibrium, a liquid with individual component in a certain concentration will have an equilibrium vapor in which the concentration or partial pressure of the vapor component have certain value depending on the liquid component concentration and the temperature. The converse is also true. If a vapor with component of a certain concentration or partial pressure in the vapor liquid equilibrium with its liquid, then the component concentration in the liquid will be determined depend on the vapor concentration and on the temperature. So let us talk about the phase of equilibrium in food that is presented in two aspects, which is in the food product and the food processing. So phase equilibrium is presented in our everyday life in many situations, such as in preparing of the coffee, in the solution of sugar in the juice, or in the tasting of creamy ice cream. Furthermore, for a previously prepared food, the phase equilibrium was already present in a certain stage of its processing, as in the edible oil processing.
Assalamualaikum and hello. My name is Muhammad Farhan, and I will explain about what is thermodynamic, or in other words, thermodynamic description. So the field of thermodynamic describes when the vapor and the liquid equilibrium is possible and its properties. Much of the analysis depend on whether the vapor and the liquid consist of a single component or they are a mixture. In other words, multi-components. So, food in a sense are multi-component and often multi-phases system. Food engineers need to understand not only the process but also the variations and modification that such a system may undergo during the process. For this reason, the structural characteristic of a raw material and its composition and also the potential variation need to be taken into account in the preparation of the material and in the definition of the type of process and operating condition. So I will continue to the next slide, which is there are two types, which is the first one is pure, or in other words, single component system, and multi-component system. What is a single component system? If the liquid and the vapor are pure, in that they consist of only one molecular component and no impurities, then equilibrium state between the two phases is by the following equation. So, pressure liquid equal to the pressure vapor, temperature of the liquid equal to the temperature of the vapor, and molar Gibbs of the liquid equal to molar Gibbs of the vapor. In other words, the Tp and molar Gibbs free energy are the same between the two phases when they are at the equilibrium. So for the multi-component system where the vapor and the liquid consist of more than one type of molecule. Describing the equilibrium state is more complicated. For all components in the system, The equilibrium state between the two phases is described by the following equation. So the first is pressure of liquid equal to pressure of vapor, temperature of liquid equal to temperature of vapor, and molar Gibbs of the liquid equal to molar Gibbs of the vapor, where P, T, and G for each phase within the liquid and the vapor respectively for each phase. So that's all from my part. I will pass to the next presenter. I hope you all understand what I'm explaining in this slide. So thank you.
So next, I will continue with the example of VLE application in the juice industry. In the juice industry, where two different sectors of the industry require information on phase equilibrium. The first one in the concentration of juice, and the second one in the recovery of volatile compound. So, fruit juice are aqueous mixture extract from fresh fruit. This aqueous mixture contains variety of constituents such as sugar, carboxylic acid, salts, pectin, and many other things. So in general, the concentration of juice and pulp is done by evaporation conducted at atmospheric boiling temperature of the product. Those calculations are performed at VLE condition, but during the processing of the concentration of juice, several volatile compounds are removed naturally. So, we need to do the recovery of volatile compound by adding chemical compounds which bring back to the fresh aroma of fruits. So, contohnya kalau kita nak kita punya juice tu ada aroma of mango, so kita kena tambah ethyl butanoate and ethyl butanoate, so that dia akan ada aroma of mango. So, the recovery of aroma is generally performed by stripping or fractionating columns, whose analysis are also use the VLE data in order to perform the optimization of the processes. So there are several other applications which in the aerobic fermentation process and the fractional distillation process of crude oil. Next, I will pass to Iman to explain more about the importance of the VLE.
So next, we will proceed with the importance of VLE. VLE are mostly needed in design and operation units, especially for separation units. It depends on the difference of separation, which are liquid and liquid or vapor, and solid or liquid and solid system. Second, vapor-liquid equilibrium information is useful in designing columns for distillation, especially fractional distillation, which is a particular specialty of chemical engineers. Distillation is a process used to separate or partially separate components in a mixture by boiling, or it is known as vaporization, followed by condensation. Third, VLE diagrams are important to locate where is the dew point, bubble point, and flash condition, because all these factors are important for the application in the industry.
Hi, it's me Hakim. So I'm going to talk about why is it important. So vapor-liquid equilibrium are mostly needed in design and operation units, especially for separation units. It depends on the difference of separation, which are liquid and liquid, or vapor and solid, or liquid and solid system. Secondly, the vapor-liquid equilibrium information is useful in designing columns for distillation, especially fractional distillation, which is a particular specialty for chemical engineers. Distillation is a process used to separate or partially separate components in a mixture by the means of boiling, followed by condensation. Thirdly, the VLE diagram are important to locate where is the dew point, bubble point, and flash condition, because all of these factors are important for the application in industry. The VLE data of binary mixtures is often presented as a plot, as shown in the figure on the right. So the VLE plot expresses the bubble point and the dew point of a binary mixture at constant pressure.